So in this video, we'll be looking at calculations under simple AC circuit. The first video and the second video already gave an overview, a complete overview on what to expect in AC circuit. So this particular video is just to apply some of those concepts that we have learned. But in order to refresh our heads on some of those things, I've compiled all the formulas that you need to know under AC circuit for your examination. So the first of them is you must know the instantaneous voltage and the instantaneous current in an AC circuit. So we have explained that AC circuit, the instantaneous voltage and instantaneous current, of course, is instantaneous because it changes with time. Okay, so it follows a sinusoidal waveform. When you plot a graph of V against T or a graph of I against T, you get a sinusoidal waveform. Okay, and this is the equation. This is the equation for instantaneous voltage and current, where V is the instantaneous voltage, V naught is the is the peak value of voltage, omega is the angular frequency, and T is the um, time at time in seconds. Okay, and we have our peak, our r.m.s value. Our v.r.m.s is v naught divided by root 2, and in the video I explained why is it v naught divided by root 2, and i.r.m.s is I naught divided by root 2. So this is a very important formula under AC circuit. Another one is the reactance formula. How do you calculate the reactance due to a capacitor and the reactance due to an inductor? Capacitor and reactance due to a capacitor is denoted by Xc, which is 1 over 2 pi Fc, where F is frequency and C is capacitance in farad, capacitance of a capacitor in farad. Also, inductive reactance is denoted by Xl, and the formula is 2 pi Fl, where L is inductance of an inductor. Xl and Xc they both have the unit of ohms. They are measured in ohms. Okay, so, and you must know the definition of reactance. Okay, it has been tested in the past question before. Define inductive reactance, define capacitive reactance, or define reactance. So you have to know that that is the opposition to the flow of alternating current due to a capacitor or an inductor. That's what we call reactance. Okay, while impedance is the opposition to the free flow of electric current due to capacitor, inductor, and resistor. Okay, that's what we call what? Impedance. Though, as I said, it could also be resistor and inductor alone, or resistor and capacitor alone. So take note of that. Take note of that. So we also discussed the is obtained. Okay, I derived this particular phase angle formula in the previous video. Now, of course, impedance is somehow related very close to the Ohm's law, which is V is equals to IR, but this time it is V is equals to IZ. So if you make Z the subject, you say that it's V over I. Okay, and we know our Z is this. Also, our V has a similar formula as this, which is also V. Okay, V is equals to V is equals to VR squared um, plus VL squared minus VC squared, the square root of this, the square root of this. Okay, the square root of this. This formula also holds. Let me rewrite the formula properly here. Okay, so we have V is equals to the VR squared plus VL squared, or VL minus, so that's a mistake, VL minus VC all squared. This is the correct thing. Square root of this. This is not correct. Okay, so take note of that. So the formula is somehow very similar to the arrangement of the impedance, only that you replace XL and XC with VL and VC respectively. So the phase diagram, if it is the phase diagram for the voltage that you want to sketch, you replace Z with VR, we replace Z with V, you replace R. Let me zoom in a little so that you can see what I'm showing here. You place R with VR, you place XL and XC with VL and VC respectively. Okay, then if you want to get your phase angle, the tan of the phase angle is equal to VR or VL minus VC all over VR. You can also use that relationship to get your phase angle. So take note of that. Then that the ratio of the V to the I to the alternating current is our impedance. In the case where we have RLC in the circuit. Now, at the point of resonance, at resonance, VL is equal to what? Is equal to VC. Okay, and we mentioned in the last class that that is when the impedance is minimum. Okay, the impedance is minimum when VL is equal to VC, and at that point, current is maximum. We mentioned that in the last in the last video. So another formula we need to also know is power relation. The instantaneous power is calculated as P equals to V times I. V is the voltage, I is the what? Is the current. So for us to calculate average power, we multiply VI multiplied by the power factor. In the last video, we mentioned that the power factor is cos phi. Okay, the cosine of the phase angle is called the power factor. So take note of all those formulas. So all these formulas are going to be very, very important in calculations. That's why we are looking at them again. So of course, these are some definitions. We are not going to be sketching the graph, this particular graph yet, because the data is not available in this video. So as at when this video is being recorded. So let's move on to the question. Now the first question we have here is a question. Said the question is the current I in a sinusoidal AC circuit is given by I equals to 40 sine 50 pi t, where t is time in seconds, and so use the equation to determine the frequency and the peak value. So they want us to use the peak value, then we get the r.m.s values of the current. So let's go straight to that. Now, what do we have? First thing is extract what we have. The question gives us that I is equals to what? 40 sine 500 pi t. So this information was given. Okay. Now we recall that the general equation is what? For an instantaneous current is I naught sine omega t. So from here we could quickly see that our I naught, the peak value of current, is 40 amps. Straightforward. So peak value can easily be calculated. So this is our what? This gives us the peak value of current. Okay, that's the amplitude of this sine wave, of the sine waveform is 40. Okay, while for us to get the frequency, we can just say, recall that if you compare the two equations, you see that we have our omega is equals to 500 pi. Our omega is 500 pi. If we compare these two equations, equation 1 and equation 2. Okay, from here we recall that what is omega? Omega is 2 pi f. So omega is 2 pi f equals to 500 pi. And you are looking for f, so you have to divide both sides by 2 pi. So if you divide both sides by 2 pi, we'll be able to get our frequency as 250 hertz. So with this, we have been able to calculate the frequency, and of course the peak value can be obtained directly from the graph, from the expression. So from there, frequency is calculated, peak value is calculated. So we need to find our RMS value. And you agree with me that what's our RMS value? Our RMS value is IRMS is I naught divided by root 2, which is what? Which is 40 divided by root 2. Or you could rationalize. If you want to leave your answer in short form, that is 40 multiplied by root 2 over root 2 multiplied by root 2. So you get 40 root 2 divided by 2. Okay, which will give us 20 root 2 as our 20 root 2 ampere as our IRMS value. So from here, we are done with the first question here. Okay, we've been able to calculate the frequency comparing the two relations, the general form and the given form. Okay, then we calculated our peak value. The peak value is staring right at you as 40, because that's the amplitude of that wave function, and that's the peak value, the highest possible value of that current. Okay, then our RMS value, the relationship for RMS value is always I naught over F over root 2. So if it is voltage we are looking for, then it's going to be what? It's going to be VRMS equals to V naught over root 2. But in this specific case, the relationship given is in terms of current. So other things that can be asked in this question now, you could be asked to calculate the period. So if you are asked to calculate period, of course, you know to calculate period, we have discussed in the previous video that period is inverse of frequency. So it means if you want to get period in this particular question, it is going to be 1 over 250. Okay, then you compute your answer, you get your answer in seconds. Okay, so take note. The question could also have asked you to calculate your angular frequency or angular velocity, which is 500 pi rad per seconds. So directly comparing the two equations directly, we can figure out what's the angular frequency from there. So also take note. Okay, so that's all the information we could extract from that particular question. We don't have an impedance, and we don't have any impedance nor a reactance, so we might not be talking about voltage, except if the voltage was given directly. So we move on to the next question. So in the next question, what do we have? So in the next question, said an inductor of inductance 100 millihenry, 100 millihenry, and a capacitor of 2 microfarad, capacitance 2 microfarad, are connected in series in an AC circuit. Calculate the frequency at which the system resonates. So this is a case of what? Of resonance. This particular question is also from the past question. So they want you to find the frequency at resonance. Okay, and if you remember, in the previous video we have derived the equation at resonance. Okay, we derived that at resonance. Let me zoom in a bit. As resonance, the frequency is 1 over 2 pi square root of LC. Okay, 1 over 2 pi square root of LC. So all we need to do is look at the given question and extract all the given information. Then you will get your answer without any stress. So I'm taking off. Let me clean this so that we can use the same space. All right, so what do we have? We have our L. Let me use a green ink. We have our L. L is given to be 100 millihenry. So don't mind that double M that is there. It's millihenry. And our capacitance of capacitor is given to be 2 microfarad. Of course, you agree with me that 100 millihenry means 100 times 10 raised to power minus 3 Henry. and 2 microfarad means 2 times 10 raised to the power minus 6 farad, and pi is given, of course. Then what do we know? We know the formula is what? The formula for angular for resonance frequency is 1 over 2 pi, the square root of LC. This is the formula at resonance. So from here, all we just need to do is to substitute everything we have. Then we punch our calculator. So 1 divided by 2 multiplied by 3.14. That's what they say we should use pi as, 3.14. And we have square root of, let's just compute that square root separately. The square root of LC can be computed as what? It can be computed as 2, as the square root of 2 times 10 raised to the power minus 6 multiplied by 100 times 10 raised to the power minus 3. Okay, so 100 times 10 raised to the power minus 3 is 1, 2, 3 is 0.1. So it means what we'll be left with is square root of 2 times 10 raised to the power minus 7. Okay, square root of 2 times 10 raised to the power minus 7. So we have square root of 2, let me punch calculator, 2 times 10 raised to the power minus 7. Okay, then we multiply that by 2 times 3.14. Okay, then you say 1 divided by answer. So we'll get our frequency. So if you, sorry, let me erase this. So with that, if you substitute everything, you see that you get your F naught to be 356.061, which, or 062, which if you approximate, you get 356. Let's just say 356.06 hertz as our resonance resonance frequency. So you can also double check and be sure that is what you also get upon computing. It's as easy as it has been done. Okay, so the frequency where there is resonance, and we have derived in the condition for resonance that we have learnt in the past is that XL must be equals to XC. Equating XL and XC, you remember that your XL is 2 pi FL and your FC is 1 over 2 pi FC. So crossing multiply and collecting, like, crossing multiply and rearranging, making F the subject. That is how this F resonance frequency has been derived. So you don't need to be suffering yourself to go through this derivation every time. Just remember that your resonance frequency is 1 over 2 pi square root of LC. Then substitute all the given values. Upon substitution of all the given values, you are going to get your what? Your resonance frequency. Easy peasy. Now, the next question we have now is, okay, the question gave, there's a diagram given in the question. We have a diagram. Okay, we are done with this, so let me erase it. So I want us to be able to finish up everything, so we'll be doing everything together. So in this case, we have a diagram of a circuit, of an AC circuit, and we can see that we have an AC source here. This is a symbol for an AC source. We have an inductor with an inductance of 0.9 Henry, and we have a capacitor with 500 over pi farad. Okay, so the question says, if the frequency of the AC circuit illustrated above is 500 over pi, what would be the reactance in the circuit? Wow, what would be the reactance in the circuit if they give a condition? If the frequency of the AC is this, what would be the frequency in the circuit? So what can we say about this particular question? We have inductor is given. Okay, sorry, that means this diagram is not correctly drawn, I guess. See the capacitance here. The capacitance is 2 times 10 raised to power minus 6. That means this value we are seeing here is the value for the frequency. 500 over pi is the value of the frequency. Let me write that in red ink. It's 500 over pi as our 500 over pi hertz as the frequency, while the capacitance is 2 times 10 raised to power minus 6 farad. I think this is the correct. This is the correct. This is the correct. The correct thing. So 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 let's move on. So let's quickly finish this. So now, based on this information, what do we have? We have our f to be 500 hertz, 500 pi over hertz, 500 over pi hertz, and we have our L to be 0.9 Henry. We have C to be 2 times 10 raised to power minus 6 farad, I guess. Then we want to calculate frequency, and since in the circuit uh, we have both XL, and we have an inductor and we have a capacitor. So the instruction is to calculate the what? Is to calculate the frequency. So how do we go? How do we go about this? Then we have to recall that, of course, the question did not specify that it is at resonance. We don't know if this is already at resonance. And since we don't know it's at resonance, we cannot just jump to saying f is equals to 1 over 2 pi 2 pi f 1 over 2 pi square root of LC. We cannot jump to that. Okay, so now we need to calculate our reactance for the entire circuit. So I will recall that the impedance, you remember the formula for impedance. The formula for impedance is the square root of this, r squared plus xl minus xc all squared. Now, but recall that we don't have a resistor in this circuit. And since there is no resistor in this circuit, impedance for this case will eventually become xl minus xc. Okay, how is that gotten? If you substitute, let's take it step by step so that I can show you how I brought out, how I got this question or this formula. So z is equals to what? The square root of 0 plus xl minus xc all squared. So since there is no resistor, so we are going to have square root of xl minus xc all squared. So the square root of a square will eventually cancel out. So we are going to have xl minus xc. So in a case where we have only inductor and capacitor, just remember that your impedance or your reactance in this case is going to be xl minus xc. So in this case, since it is inductor and capacitor that is present, instead of calling it impedance, we can call it reactance. We can call it the effective reactance. So that's why the question is asking you to calculate the reactance, because there is no resistor in this case. So how do we go about this now? We need to calculate our XL, and our XL is what? 2 pi um, FL minus, and our XC is 1 over 2 pi FC. So all we need to do is to substitute everything we have. So let's substitute everything we have. So this is 2 pi multiplied by 500 over pi multiplied by 0.9. Our h is given to be 0.9. Okay, then minus 1 over pi. Capacitance has been given to be 2 times 10 raised to power minus 6. So pi eliminates pi. Pi eliminates pi. If you multiply this will eventually be, this is 2 times 500 is 1000. 1000 multiplied by 0.9, you are going to get 900. So 900. So upon multiplication of this, you have 2 times 2 times power minus 6 will give you 10 raised power minus 3. So eventually 10 raised power minus 100, it's going to be 400 ohms. So that is how to um, go about this particular question. Okay, so let's quickly have a recap before we let's have a recap on that question before we proceed to another question. Okay, so in the question is, we have a diagram. As I said, the diagram is not correctly drawn. This 500 over pi is the frequency. Okay, then the inductance has been specified, the capacitance has been specified. Then we are calculating the reactance of a circuit that contains only an inductor and a capacitor. Since it contains only an inductor and a capacitor, just remember that a circuit that contains inductor and a capacitor, Z is always equals to XL minus XC. So our XL can be computed by 2 pi f multiplied by L minus 1 over 2 pi f divided by 1 over 2 pi f multiplied by C. So substituting all the given values without any stress, we can quickly compute the reactance due to the inductor and the reactance due to the capacitor. Then we take the difference of the two to get the effective reactance in a circuit that contains okay, so we have so in the next video I'm going to make another we are going to have another video that continues with the rest of the question. So um, check that video for more questions.